Welcome to the video tutorial for building and testing generators developed for the wind farm project. In this video tutorial, we're going to walk you through a few basic steps. First, installing magnet drivetrain into its housing. Second, winding coils. Third, assembling generator onto wind experiment kit head. And finally, measuring voltage using a 10 ohms resistors as load. The magnet drivetrain is formed by the shaft, the magnet, bushings, and an 8-dance gear. The magnet drivetrain is placed into the housing, which is kept together by rubber bands in this demonstration. Note that when turning the gear, the magnet should turn as well. Before you start winding the coils, leave 2 to 3 feet of wire hanging free. Start winding the bottom of the plastic housing, making sure not to cover the bolt channels. In this demonstration, we are winding 150 turns first onto the bottom. Then we start winding 150 turns onto the top. The direction of the winding should be kept the same. When you're crossing the wire toward the top of the housing, don't let it touch the shaft. Once you're done winding the top coil, leave 2 to 3 feet of wire hanging free too. Here, you can see the coils winded onto the bottom and top of the jam pack. It's helpful to use tape to secure the first and last winding in place. This is the wind experiment kit head, mast, and base. The kit that you will receive has a new plastic tripod. Instead of using the steel bolts that come with the wind experiment kit, we use the nylon rods that are included in the jam pack. These nylon rods are not magnetic, therefore they will not interfere with the magnetic field of your generator. The two 1/2-inch pieces of tubing are meant to avoid bending of the nylon rods due to vibration of the moving turbine. On the other hand, for this demonstration we used hot glue to hold the blades firmly onto the wooden sticks. Regardless of the material that you decide to use, the goal is to prevent bending of the blades, which creates drag. The height at which you place the generator onto the nylon rods needs to be adjusted so that the gear of the magnet drivetrain and the larger gear of the turbine shaft mesh smoothly. The gear ratio of a gear train is the ratio of the angular velocity of the input gear to the angular velocity of the output gear, and it can be calculated by the number of teeth on the gears. In this particular wind turbine, is 64 dents divided into 8 dents, which gives a gear ratio of 8. Increases in gear ratio will cause an increase of the rotational speed, but also a decrease in torque, which is the twisting force acting on the magnet drive train. Scrape the insulation off the ends of the wire leads of your generator using sandpaper, and then connect them to the two center leads of the rectifier using alligator clips to transform the alternating current into direct current. The output terminals are labeled positive and negative on each side of the rectifier, and they are connected to a 10 ohms resistor, and we are measuring voltage across the resistor. For this demonstration, we recorded an average of 600 millivolts, which is approximately 9 times higher than the 70 millivolts generated in the previous blade testing experiment. By using Ohm's law and the data recorded in our experiment, we can easily calculate the electrical power generated by the wind turbine. We generated 600 millivolts using a 10 ohms resistor, which produced 36 milliwatts. Finally, possible variables to keep in mind for testing your generator are the following: number of turns on your coils, size or diameter of the copper wire, magnet size, and also rotational speed of the magnet drivetrain. As a note, for this demonstration, we used 150 turns of a 28 gauge wire.